engineering. So if you refer to that video recording, you'll be able to catch up to where we are right now. Okay,
thank you.
Yes. So now that we're recording, let me just. So these are the learning outcomes we're going to cover. I already went through them and the introduction as well. And we were talking about the software process, and this was mentioned in Unit 1 as well. That it's the different fundamental activities, and listed here, there's only 4 of them. They're in summary. We said software specification talks about you trying to get the requirements from the customer. And after you have the requirements, then you develop some sort of document, which is a specification document, and you can give it to the people who are developers, okay? And they're able to code that or bring that system to life. So after the system has been coded, there needs to be some sort of validation, and validation involves you trying to measure what you did by looking at what was supposed to be done, okay? So you're trying to measure whether you met the requirements and everything works and so forth. And then we have software evolution, where the software will gradually change as time goes by to meet whether the organization is changing or the environment around you is changing, but the software as well will evolve and change. And that happens through maintenance. So that's the other stage. So we have these 4 main processes, and they can be, or they were adapted to create other models, okay? And while we're on the topic of models, we're going to be focusing on 3 types of models here. We're going to be talking about the waterfall, which you may be familiar with from your other modules. This is a very linear sequential model, okay? And then we have what we call the incremental model. Here, what we do is we develop several versions of the system up until the required one is complete, okay? And then we have what we call the V model. And with the V model, the testing phase runs in parallel to each development phase. And I have pictures of them here, so we're going to focus on each one individually. So if you look at this picture of this waterfall model, so if you are adopting this model to developing software, I'm sure you can see it does look like a waterfall. I tend to have this argument with my students on campus, whether this thing looks like a waterfall or not. It actually does look like a waterfall. So what happens is this would be the first phase, and there's a breakdown of what happens at each stage, okay? So they've taken this software process activities and they've created models, more detailed specific models, which define what happens at each phase of the project. So at requirements, you're going to be speaking to the stakeholders. I'm just going to be elaborating on the waterfall specifically, but what you'll see is with the other models, the phases are still the same, okay? It's just that they are structured differently. So what happens at the requirements is that you speak to the stakeholders. You try to find out what exactly are they trying to achieve with this system. Okay, some other people may argue that there should be another phase before requirement, which focuses on planning. And when we talk about planning, we're talking about looking at budgets and talking to stakeholders, trying to do a feasibility study before the requirements are done. So once you know if you have the money, you have the human resources to actually achieve this project, then you go ahead and do the requirements. But by the time we get to the requirements phase, what we are actually doing is we're speaking to these stakeholders, and there's different techniques that we can use to get the requirements for them. We can interview them, we can give them questionnaires, we can do observation, we can research what other developers have done when they are faced with a similar problem. So that's what we do at requirements gathering phase. So once the requirements are well understood then we move on to the design. We start to design the system and we do drawings. We design the database, we draw the ERD, we draw the user interface diagrams and so forth. And once the design is cleared, then you start to develop. Now you have a visual idea or representation of this system, and the coders can write the code to create the functionality in the backend. Then once the coding is complete, then they move to testing, and there's different forms of testing. You can test individual components, you can test the system when it's integrated, you can test whether users can actually use the system, usability testing. And the next one is we're covering the deployment, okay? So once you're satisfied with your test results, you now need to deploy the solution to some server. Remember the environment at which you're using to build the system and the environment at which the system is actually going to be operational are different. And so the environments will be very different in terms of operating systems and resources. Maybe on your computer, the software that you are building works perfectly fine. But once you deploy it to a server which you share with other customers, then you start to experience some sort of issues. So it's very important that in some instances you're going to find that they test during the deployment phase, because you actually need to also test in the live production environment, not only at the local environment, for the reasons that I just specified just now. So they usually combine. You're going to see different variants of this waterfall model, but they all lead to the same thing, okay? Different organizations have tweaked them to suit their philosophy. So after the system has been deployed to the production environments, then we have what we call maintenance. And there's different types of maintenance as well. You maintain something because something went wrong. You can also maintain it for the sake of maintaining it. It doesn't mean there were errors and so forth. It's more like a preventative measure. And you can also do maintenance in the form of upgrades, okay, software upgrades. So this is the waterfall model, and this is how it looks like. And what are the advantages of using the waterfall model? All stages are well defined. It is simple to use and easy to understand. It is good for small projects, okay? Remember that this is a sequential model. We only go in one direction. Once we finish with requirements, specification, and we move to design, we cannot go back. So this is best suited for small projects. And this model is easy to understand. It's very simple, okay? It's in its basic form. So what are the disadvantages of this model? It doesn't accommodate changing requirements. So if a customer, you can't use it for big projects, because if a customer does not tell you all the requirements beforehand, then you miss a particular requirement, you cannot go back. Once you're in the design, you cannot go back now and make those changes. It is not good for complex and object-oriented projects. Okay, for very big, complex projects that involve multiple objects and so forth, it is not good. And there is a high amount of risk. So there's high amount of risk of failure here, specifically for the fact that you cannot go back. So what if the customer actually comes back to you while you're at the testing phase to say they forgot to mention XYZ? Now that poses a risk to the entire project because it could fail, okay? So that's the disadvantages of using the waterfall model. Then we have the incremental model. And this one is more iterative and more agile in the sense that we create multiple, as you can see, we create multiple iterations or multiple builds of the system up until we get a product that is complete, that we are satisfied with. Okay, so we can go in iterations. Remember, a build does not necessarily mean it's gonna get released to the to the customers for usage, okay? A build can be something on a computer, a version that you create, but you're still not satisfied that this thing is ready to go into the market. So what they normally do is we create, using the incremental model, we create multiple builds up until the customer is satisfied. Then from there, we create what we call a release. Then a release is what actually goes up to the customers to use. There's also a different variant to this incremental model, and we call it the spiral model. It does the same thing. It's agile. As you can see, it's going in circles, okay? All the phases still remain the same, just like how they are in the waterfall. But the difference with these is that they're more agile. You keep on going in circles until you are satisfied with the customers, you satisfied all the customers' requirements. So what are the advantages of using these agile approaches, such as the incremental model and the spiral model? It promotes customer feedback during the development process. There's an early delivery and deployment of useful software to the customer, and it's easy to manage risk. Okay, so one thing you can take out of this is that with this particular agile approaches, you would minimize the risk of failure. Okay, we're not really concerned about trying to predict all the requirements of the project, because you can always go back and add whatever we missed by creating a new build. So there's reduced risk, and there's also understanding between the developers and the customers. So what are the disadvantages? There is a need for proper planning. System structure tends to degrade as new additional modules are added. Okay, in regards to planning, when it comes to the agile approaches, you don't focus so much on the documentation. Yes, you have to be clear in terms of how much money you're working with, how much people are going to be involved in the project, what is the time frame of the project. So there is some sort of planning that is done, but we're not really too much focused on creating documentation, because we have to leave room for adjustments or changes. Okay, so the customer can come back to you and say, oh, look, we forgot to mention this, and then it just renders all the documentation void that you just created. So there is need for planning, but the focus is not really much on the documentation side of things. And system structure tends to degrade as new additional modules are added. So as you keep on going in circles, the system structure can tend to degrade, okay? There could be a lot of contradictions between what the customer is telling you between the different builds, and that could end up compromising the system structure. So yes, it minimizes risk, but it does have some sort of disadvantages to it. And then we have what we call the integration and configuration module. This incorporates reuse-oriented software engineering, where certain functionality or modules are integrated to existing system, has the following stages. So what if you are actually not building the system from scratch, but you are adopting components or an entire system that's available off the shelf? So you have that option. Instead of having to adopt the spiral model and the waterfall model, you have an option of looking around you. What exists? What can we get off the shelf to solve the problems that are experienced by the customer? And you can see that similar to the other models, you start with a requirement specification where you're trying to understand what features the customer would require out of the system, okay? And then we move on to, unlike the previous models, we move on to software discovery and evaluation instead of design, okay? Because what we're doing here is that we're trying to figure out what the customer is trying to do, and then we move on and we search in this phase, the second one, we search the market to see, are there any components that we can reuse instead of building everything that is in the requirement specification from scratch? Are there any components out there that we can reuse so that the product gets to the market faster? Okay, For example, if you are doing a search feature on a website, if the customer said, I wanted my customers to be able to search for products on my website. Here, what you're going to be looking for is there a tool or add-on or a component or framework that you can adopt for the search feature onto your website? Maybe a plugin from Google that you can just sort of plug and play into the website so that you don't have to build it from scratch. It saves you time. It's more of a reused orientated approach. So once you search and you find what you're looking for, then you move on to the next one, which is requirements refinement. So you adjust your requirements accordingly by looking at what you actually found, what components did we find, and based on that, then certain ones will be, we have to remove them because you no longer have to build them yourself. Okay, so then you go back and you do a requirements refinement. Once you've done your requirements refinement, then we have what we call systems application configuration. Sometimes what's going to happen is that while you're looking for the component, you actually find the entire system off the shelf. So if that's the case, then you will stop at the application system configuration phase because you're just going to sort of adopt the entire system. However, if that's not the case, then you're going to move on to component adaptation and integration, making sure that the components that you plan on purchasing are functional with the type of platform you plan on using or the programming language, and you actually be able to integrate them onto the existing system. Okay, so this integration and configuration speaks to software reuse as an alternative to building software from scratch, from the requirement specification all the way to maintenance. We look for an alternative of something that's already off the shelf. If it exists fully off the shelf, then perfect for us. If some parts of it exist component-based, then we attach those components as well. Okay, so moving on to the next model. And this is what we refer to as the V model or the V&V model. It's named differently in different places, but it's funny if you just refer to it as the V model. So this V model is I would say it's an improvement on the shortcomings of the waterfall, because the problem with the waterfall is that it's too linear and sequential, and once we move on, we don't look back. So what happens here is that we go into main phases, a phase of verification and a phase of validation. And what happens is the phase of verification does not deal with code. You don't touch the code there. We are looking at addressing issues of planning and requirements gathering. We're verifying the customer's needs throughout. Once we are satisfied with that, then we start coding, okay? Then the process of testing the actual code happens in the opposite direction, okay? So we would already be done with all of these processes as part of your verification. Then you go and do your testing in the opposite direction. In this particular instance, we reduce the risk that comes with the waterfall model by running the testing in parallel to each of the verification processes. Okay, so this V model is an improvement on the waterfall, and it's best suited for very mission critical projects where you cannot run a risk of failure. So the next concept we're going to be talking about is prototyping. So what is prototyping, and how is it useful? It is essential so that the costs are controlled and system stakeholders can experiment with the process at an early stage. It allows customers, stakeholders, or even potential users to see how the system supports their work. It can be used as a way of revealing errors and omissions in the system's requirements. So prototyping is basically creating an early working version of the system or a demo, okay? And the purpose of that is to give this prototype to your customers or the stakeholders. Remember, stakeholders, we're talking about the people that are involved in the projects. It's not people who own shares in the company, although they may be stakeholders in the project as well, but stakeholder doesn't mean someone who owns shares. Even an employee, a regular employee, can be a stakeholder because they want to know how this system will affect their work. Okay. And some of the benefits, of course, of prototyping is that you involve the stakeholders, you get feedback at an early stage, and also the people get to accept the system before it comes into production. You involve them as part of the process of building the system so that when it's out there, they do not reject it, okay, and shy away from using it. So that's the purpose of us doing prototyping. It's very useful for the high risk software development models. You give the users a prototype so that the development team and the customers are on the same page to some extent. Process improvement. It is a way of enhancing or improving the quality of a software, reducing costs, or accelerating development processes. So there's a need to constantly improve your software development processes so that they yield good results. Okay. They say that two approaches to enhance quality software. So we have what we call the process maturity approach and the agile approach. The agile approach, such as your incremental or your spiral models, are a way of producing quality software by going in iterations up until that the customer's needs are satisfied. Also, you can shift the focus to your processes. How mature are your processes? Okay. Let me just go to the next slide so you see what I'm talking about. So we refer to this as the capability maturity model. Please, this is not an SDLC model. Okay, this is a model to measure at what level are your software development processes operating at? How mature are they? Okay, so let's explain each phase of this capability maturity model, or you can also refer to it as the process maturity model. You realize that in your study guide, they don't really have a drawing of it, but they have listed the processes there. So this is the first one, it's initial, okay? And any company that's operating at this phase, they're just a startup, okay? Maybe it's just you and your friend starting a software development company. Everything is unplanned. It's ad hoc. Everything is just ad hoc, okay? Your plan as your goal. It's not good to remain at initial phase for too long, okay? And you need, as a software development company, you need to make sure that you're always aiming to be a step higher. Anything you do in life, you're going to find out you need to be a step higher. So same thing applies here. You're just starting off, everything of yours is unorganized and so forth. Then you move on to a step higher, which is the repeatable phase. So if your company is operating at the repeatable phase, it means that you have adopted some sort of structure as a company, but you still don't have standardized processes. So perhaps now you've grown and you have a sales department, you have an IT department with the developers, you have a marketing department and so forth, but there's a lack of documentation surrounding what needs to be done. So a lot of the things they end up doing and repeating, okay? Maybe the people at sales end up repeating something that has already been done with the people at marketing because of that lack of standardized processes. So if you're operating here, you have some sort of structure, but it's just that there's no defined process standards. And then if you go a step higher to the defined phase, if you're operating at this phase, it means there is structure and there is also documentation. So now when you're faced with a particular scenario, you know that there's a particular document at which you can refer to because the processes have been well standardized, okay? So that's a level 3 level of maturity in the processes. And then above that, we have the managed phase. And if you're operating at this phase, it means now you are able to place metrics, okay? You're able to place metrics and measure your outputs because the organization is now well managed and you're able to specify, okay, we plan on being the leading software development company in the country. And to do that, we have to obviously be better than our competitors. So we need to put in place key performance indicators so that we achieve that goal in time. Let's say maybe we projected that we're going to be the leader in the next 10 years, okay? So we need to put in key performance indicators to measure our output per year. So by putting those goals in place, you're able to measure, you know where you want to be, and you know what needs to be done in order to get there, and you're able to put numbers or measures in place to measure whether you're actually moving fast enough. And that's what it means when you're operating at the managed level of the capability maturity model. And then the last one is optimized. And here you're at the highest level of maturity, but it does not mean that you've like essentially peaked. You need to still do some sort of, that's why they refer to it as optimized, because all you're doing here is you continuously improvement. It's called in continuous improvement. You're continuously improving your processes, adding on, trying to make them better because the environment around you is constantly changing. So your processes as well need to sort of adjust to that change. So don't get confused. This is not an SDLC model for developing software, but it's to look at your processes as a company to say, how mature are your processes? Because that determines the quality of software that you end up delivering, okay? And then, in conclusion, software processes can be defined as a set of related activities which leads to the production of a software system. Even though there are different types of software systems, there is no universal software engineering method applicable to them. So there is no blanket approach model that you can adopt as an organization. You need to look at the factors surrounding the project. What is the size of the project? What are the specifications of the project? What is the level of risk? All of those things determine which approach you end up applying. There are 4 fundamental activities which need software engineers to be taken into consideration during software process: software specification, software development, software validation, and software evolution, which we mentioned were basically a summary, and they were taken and they were adopted to create specific models that can be applied to different factors. And during software process, the following models can be used depending on the type of system, size, and requirements analysis: the waterfall, the incremental development model, and then the integration and configuration model. Okay, so guys, that is the study unit 2, where we covered the software process. Okay, so remember what I said, guys. Friday, we will move Friday's class to next Tuesday because we're supposed to be doing this study unit again next Tuesday, but we already have a recording of it.